Hello. In this video, I want to show you an amplifier. It's like an op-amp actually, made of all transistors. And I have it simulated in Falstad. And I'm going to put a link in the video where you can get Falstad. It's a free JavaScript simulator. You can either use it online or just download it. It only takes a few hours to learn. It's really handy. And so in this amplifier, I haven't actually had a chance to build it on a breadboard, but it works in the simulator, so I imagine it should work on the real world. And so what we're going to show you here, everything here I've sort of calibrated. So if you look at this is like your feedback R1 or R2 for the gain of the op-amp. This is tied to 0 volts. So it's roughly, getting close to a gain of about 10 here. And this is, set to almost give you the full input of 2 volts DC, because most of it's 915K. It's almost all going in. Maybe just it's for trimming it to get it more accurate, right? Okay, so I leave that set. Leave this one set. You can play around with the gain if you want later. But so essentially, I've got 0.2 volts coming in, and I got about 2 volts coming out. So it's a gain about 10. There's my, if I put my mouse over there, the blue line on the bottom shows you the DC coming out. This green one here is when I put my mouse over the 10 kilohertz signal. That's the signal generator, which is not connected at this time. But let's say I want to use AC input instead of DC. Well, I can do that, right? I can just put it in there, and boom, we got an AC signal coming out of here. It's more or less 2 volts. Let's see. I think that's 2 volts. Yeah, that's 2 volts. So it's about 4 volts peak to peak. Maybe a little over 4 volts peak to peak. What happened there? Let's see. Run. Oh, there. Okay. So 1, 2. Yeah, it's about 4 volts peak to peak. And you'll see I've got these resistors kind of high, but they can be lower. Okay, because I'll show you. So if you need a lower source impedance, you're driving something, 100 is pretty high. The reason I left them at 100 is it draws less power for this whole circuit, right? And I've got it biased at +5 and -5. Okay, there's my little current source for the input stage, which is a differential amplifier. Okay, so let's show you this. Let's go down here. They're at 100K. Let's put them at 10 ohms just to see what happens. Well, that's pretty low, right? 10 ohms, is that it? 10 ohms. Does it still work okay? So now you could drive, yeah, it still looks like we got a clean output. So we could drive, some kind of load. Now, let's see here. Yeah, there's my DC. It's still working, 2.1. So I can also increase this to, I think, 300 millivolts. I'm not sure what the highest I can go. 3.2 is pretty good. Let's see if I can go a bit higher than that. Maybe getting to, if I want to go a lot higher, I probably have to increase these voltages here, the minus and the +5 and the -5. I have a feeling it'll be a little more inaccurate as I go higher. But I'll just see what happens when we go to 400 milli. Still good at 400. What about when we go minus? Let's try minus. Let's put a minus on there. -4. What is happening there? Wait, happened. I don't think I put that right. Oh, okay. Wait, I didn't enter that in. -4. Enter. Oh, it's still pretty good. -4.5. So it's swinging both in minus and the plus direction is pretty good. I'm going to set that back to where we had it at what is it? 0.2. Oops, 20. 0.2. That'd be good. Okay, so yeah, we got a gain of about 10. And so that is the amp, the DC amp. If anyone wants to build it, let me know if it works okay in the comments. I don't know how accurately matched these two differential transistors have to be. And these ones here, these ones I don't think are too critical, but I'm wondering about these. So again, I haven't built it. So if you're building it, you can just try garden variety ones, and then maybe if it doesn't work well, you can try to match these transistors using your meter and try to match the current gains of these transistors, maybe these two as well. These ones aren't as critical, but these four probably be the ones you might want to play with. Other than that, I think it's pretty straightforward. I think this is just a feedback to get rid of any like maybe high frequency noise or something. So I don't think you'd have to touch that unless you're messing around with the frequencies a lot. Now, what's the upper limit in frequency? I don't really know on a practical because I haven't built it, but I know if I go here and I go too high in the frequency, watch this waveform down here. If I go to 100 kilohertz, you'll see it changes this. So is the simulator accurate? I don't know. Um, let's go down to 30 kilohertz, see what's happening there. Just trying different things. Okay, 30 is not too bad. We're getting these little spikies. Now, what I think that if we get those, I mean, there might be some optimization you can do, but let's edit this. Let's take the voltage down to maybe 100. Let's see, do we still get those spikes? Yeah, we don't get the spikes anymore. So maybe it just doesn't like the voltage levels high. Maybe you have to put some bigger cap there. Let's try that. Um, let's say you're back to 300. Okay. And let's see if we increase this, if that helps us. Let's go to 100 puff. Just see what happens. Ooh, look at that. So it doesn't like that too much, eh? It wants smaller, maybe. Edit. Let's go to 5 puff. See what happens. Look at that. Down to 5. It's pretty good, eh? We'll leave it at 5. So that's kind of neat, eh? We've got now 30 kilohertz. Let's see what happens if I go to 100 kilohertz. 100. Okay. Is it better? Well, it's better than before. We're still getting some of these. Let's further reduce this. Reduce this to 2 puff. Yeah, it seems to actually kind of improve it a bit. Again, I'm not going to spend too much time on this. I just wanted to show you some of the flux. I'll just put it back to where it was. What we were doing before. I just wanted to show you how you can kind of play around with this, and you can tinker around with the values. Now I'm going to show you. Yeah, check the link in the description. I'll show you where the link is to Falstad.com, I believe it is, but I'll put the link in the description for you. Okay, so thanks for watching. I hope you learned something on this. I'll try to come up with some more cool videos soon. Okay, thanks.